Logical operators. Yeah, I said how to work with the logical operators. So there is one more operator is there in this logical, and what is that operator here? Not. Not operator is there. But I said when it comes to the presidency of operators like and or, so which one is given first presidency and is given first, and second presidency is given to what? Or operator. Okay. So first is given to the and operation. Okay. Second is given to the or operation here. So how this is? For example, yeah, if two operators are there, suppose if you are writing 10 is greater than 5, or if I said here or, right? Okay. Some 5 is greater than 10 and okay. And I said 10 is again 5 is less than 10. So I've taken like this. But in these two operators, in OR and AND operation, which one is evaluated first AND operation, right? So what is the result of? Suppose what is the result of 5 greater than 10 false? First one is false, then second one is evaluated no. The result of this expression is what here? False. Okay, then first one is 10 greater than 5 and second one is false. Then is it 10 is greater than 5? Yes. This condition is what here? True. If the first one is a true, will it evaluate second one? No. So the result will be true one. Right? So in our operation, if first one is a true, second operator is not operand is not evaluated. Suppose if I'm writing 100 or 200 and 300. Okay. What is the result? 100. 100, right? So here 200 and 300 is what? 300. Because first it evaluates which one? And so 200 and 300 is 300. And 100 or 300 is what? 100. Right? So the result is 100. Now suppose if I'm writing 200 and 300 or 100. Yes or no? So 300. Okay. So 200 is a true or not? Yes. So first one is a true. Will it evaluate second one? Yes. Because this is which operation? And so 200 and 300 becomes 300. And 300 or 100 is what? 300. Right? So the result is what here? 300. Okay. So you have to understand. Suppose if I'm writing 0 or 200 and 300. Okay. So 200 and 300 is what? 300. So 0 means true or false? False. If it is a false, will it evaluate second one? Yes. So 0 or 300 becomes 300. Okay, 300. So presidency of this both the operators first, it will do the evaluation of and then it will do what? Or. Okay, first AND operation is done. After AND operation, it will do which operation? Or operation. First it will do AND operation and then it will do which operation? Or operation. And there is one more operator is there. And what is that operator? Not. So not actually this operator is used with, this operator is used with other operators. It is used with what here? Other. This operator is used with which operators? Other operators. It is used with other operators. What are other operators here? Like suppose you can use with like greater than operator, all relational operators, like all relational operators. Okay, even it is used with membership operators, membership operators, and with which operators? Identity operators. So this is used with all relational operators, membership operators, and identity operators. Not suppose not equal to, suppose not greater than, suppose not greater. Suppose here I'll write not 10 is greater than 2. Actually 10 is greater than 2, or is it 10 is greater than 2? Is it true or false? True. 10 is greater than 2 is a true, right? Okay. So not true means false. Not true means false here. Suppose if I'm writing 10, not 2 greater than 10. Is it 2 is greater than 10? No, false. Not false means true. Not false means true, right? So not, suppose based on, for example, if not in, suppose you are searching, for example, when you are working with the collections, you are searching for one value. For example, if you take telephone dictionary is there. In telephone dictionary, you are searching for one number. If number is not there, you add it. If the number is not there, then you add it. If the number is there, you don't add it. How can you find out? Is it not there? So you are searching. Okay, when you search, if it is a true, if it is a false, okay, not false. Not false means true. If it is not there, then I want to add it. If it is there, I don't want to add it. So you are trying to search, I mean, you are trying to compare against true condition or false condition. So that can be done with the help of which one? Not operate. So if you see the truth table, if you see the truth table of not operator, so it is like this. How this not operator is? Okay. So here is a binary operator. This operator required only one operand. Okay, it is a binary operator. So sorry, it is a unary operator, unary operator, and required how many operands? One operand. Okay, it is a unary operator and required how many operands here? Only one operand it required. Now, if you see the truth table of not operator, it is like this. How you are writing? This is operand one, and this is not. So there is operand one, and this is not operand one. If operand one is a true, then not operand one is false. If operand one is a false, then not operand one is true. If operand one is a true, then not operand one is a false. If operand one is a false, not operand one is a true. But this is used with other operators. This is used with other operators. So it is like this. Okay, for example, even if you are writing not true is a false, and not false is what again? True. Okay. Not true is a false, and not false is a true, right? So not means opposite of it. Not means what here? Opposite to the true and opposite to what? False. Tickets are not available. Not available. Available is true. Not available means false. If available is false, not available becomes true. It's like that. Okay. So if for developing certain logics, you may use which operator? Not operator. Okay. But this operator, I'm saying no, you use with other operators like all relational operators, membership operators, as well as what identity operators. Okay. Then next we'll see one more category of operators. Okay. Yes. There's one more category of operators like this. So when you see the operators list, now we have seen these are list of operators. I said about arithmetic and relational operators, logical operators. Then next we'll see which operators here, assignment. But for knowing these assignment operators, let me tell you about these operators again. That is bitwise operators, membership operators, and identity operators. Because assignment operators also uses these operators. Assignment operators also uses these operators. So let me tell you first these operators, and then we'll come back to which one? Assignment. So let us see. Let us see the operator like bitwise operator. Yeah, there is a bitwise operators are there. So the name itself, right? Bitwise operators. The name itself, you have a bitwise operators here. So what are the bitwise operators here? So bitwise. Now bit means 0 or 1. Okay, bit. One bit can be either 0 or 1. You'll say no, 8 bits equal to 1 byte. 8 bits equal to 1 byte. Bitwise operations. It means these operators perform the operation by converting into what? Zeros and ones. Or this operator works only on which data? Binary data. This operator will work only on which data? Binary. So that is data which is represented in zeros and ones. Getting on. So bitwise means it is only on binary. So when you go for binary, when you go for low level operations, because computer understand which language? Machine language. Suppose when you represent data in the form of zeros and ones. For example, if you are working with embedded applications when you're working with electronics, okay. So I think you find some logic. You find what your logic gates, right? What is logic gate? Is an electronic circuit or not? Yes, to which through which you send some bits. Okay, that is to control the power, right? So there is some logic gates. Now you find OR gate, AND gate, okay, NAND gate, logic gates. You find logic gates, right? So all these are some gates here, logic gates. So here, AND gate, OR gate, NOR gate, NOT gate, NAND gate, and one more is what? XOR gate. Okay, now these are different logical gates, right? So what is a logical gate here? See, now if you see the definition of this, so but this is low level operation or not? Yes. System level. This is systems here. A logical gate is a device that acts as a building block for digital circuits, and they perform basic logical functions that are fundamental toward digital circuits. Now, most electronic devices we use today will have some form of logic gates in this. Okay, so that is what AND gate, OR gate, XOR, not NAND gate, NOR gate, like this. Basically, you'll say five or more are there. So this is a logic gates principle. When the transistor is on or open, then electric current can flow through, and when it is off, then no current flows. When you string a bunch of these transistors together, then you get what's called which one? Logic gate, which lets you add, subtract, multiply, and divide binary numbers in any way by imaginable, right? So it means this is what operations you perform on which one? A logical circuit, right? So how this is done? By passing values in the form of zeros and ones. By passing values in zeros and ones, right? And not only that, this bitwise operators are also used to perform some low level operations. Like suppose you want to, for example, you want to mask the bits, or if you want, suppose if you are working with the operating system, memory management is it. Memory management, suppose if you are working with a C language, like suppose integer data type is there. Integer data type takes how many bytes? 2 bytes. What will happen if I give more than 2 bytes value? Then the value will be rotated. The value will be what? Rotated means the value is rotated by shifting what here? Bits. By shifting bits left side as well as what? Right side. But how this is done? With the help of which operators? Bitwise operators. So there are so many applications of which one? Bitwise operators. But bit is nothing but what? Zeros and one. So bitwise operators perform operations only on which data? Binary data, which is represented in zeros and ones, right? So bitwise operators perform operation only on binary data, that is zeros and what here? Ones. But if you don't give in binary, if you give in decimal format, suppose if I give some 25, 25 is a binary or no? 25 is binary or decimal? Decimal. Even though if you apply this bitwise operators on decimal, it will convert this decimal to what? Binary. Even though if you apply this bitwise operators on decimal, it will convert this decimal to what? Binary. And then it perform operations, right? So bitwise operators perform operation only on which data? Binary data, which is represented in zeros and ones here, right? So, so when you're talking about applications of bitwise operators, okay. So where these bitwise operators are used? These bitwise operators are used in memory management. Okay, these bitwise operators are used in memory management. Okay, it is used in memory management. These bitwise operators are used in applying which one here? Logic gates, where I can say low level or embedded applications, embedded embedded applications, right? So these are some of the areas where these bitwise operators are used. Okay, memory management, operating systems. Okay, so all these uses, which one here? Bitwise operators. So as a part of Python, you have a different bitwise operators. Now the following, so bitwise operators bitwise operators supported by Python. Now these are the bitwise operators supported by Python. One is which is called as a which operator? Shift operators are there. One is called a right shift operator, which is which is greater than. So there is a left shift operator, which is less than, and there is a bitwise AND operator, which is ampersand, and there is a bitwise OR operator, and which is a pipe symbol, and there is a bitwise XOR operator. XOR means exclusive OR operator, which is cap symbol, and there is a bitwise NOT operator, which is given with tilt. Tilt is given. Now this is called as bitwise NOT operator, and this symbol is bitwise exclusive OR operator, and this symbol is bitwise OR operator, and this symbol is bitwise AND operator, and this is a left shift operator, and this is right shift operator. So let me talk about this bitwise operators. Now, where exactly it is used in? Memory management, logic gates, embedded applications, and what is that? Operating systems. All these are the applications or application areas where you'll be using bitwise operators. So as a Python developer, you must know all the operators. I should not say that I don't know this operator. You must know all the operators and their operations, because these operators use it to perform certain operations while developing programs or while developing applications. So because of that, first you are learning all the operators and then we'll go for other chapters, right? Okay, right shift operator. Now, first one is a right shift operator. So this is a yes, it is which operator here? Right shift operator. Right shift operator is there. But when you see this right shift operator, when you see this right shift operator, the name itself, right? What is the meaning of this here? Okay, so this operator is used to shift a number of bits, to shift a number of bits towards, to shift a number of bits towards which side? Right side. To shift a number of bits towards the right side. Okay, by shifting number of bits towards the right side, what will happen is the value get decremented. Okay, by shifting, okay, suppose by shifting number of bits towards right side, the value get what here? Decremented. By shifting number of bits towards right side, the value get what here? Decremented. Suppose suppose you want to decrement value by deleting bits. But generally, how you decrement value? By using minus, subtract operator, right? Suppose a value is 10. I want to decrement a value by 5. Then what will I do? I'll say a equal to a minus 5. That is nothing but 10 minus 5 becomes what? 5. Means you are subtracting one value from value. But I want to decrement value not by subtracting value, but I want to decrement value by removing what? Bits. So decrementing it by deleting bits. By deleting bits, and that can be done by using which operator? Right shift operator. A right shift operator. Now suppose it is a binary operator and it required two operands. So operand 1, so this is operand 1. Okay, operand 1, or you can say value right shift n. So here value must be which type here? Value is which value? Binary value, because shift operators are used, binary operators are used on zeros and ones. But if you give value in decimal, even though it converts into what? Binary. Okay, you can give in decimal also, but it will perform operations on binary only. Okay, so value right shift n is nothing but number of bits. N is nothing but number of bits, means how many bits you want to shift it towards which side? Right side. How many bits you want to shift towards the right side? That is represented as what here? N. Okay, so value is which value? Binary value. Even though if you give value as a decimal, but this bitwise operators are applied only on integers. You cannot apply this bitwise operators on floats. You cannot apply this bitwise operators on any other data type. You can apply this bitwise operators only on which type? Integer type. Now this is one note you have to. So bitwise operators is a note. Now bitwise operators are applied on which values? Integer values. Okay, but even if you give integer value in decimal or octal or hexadecimal, it will convert that value into what? Binary only. It will convert that value into what? Binary. Okay, binary value. Value is a binary value. If decimal is given, if decimal or any other format is given, it converts that value into which value? Binary value, right? If any type is, if any type is given, okay, it converts into what here? Binary. Okay, then n is nothing but number of bits shifted towards the right side. Okay, number of bits, n is nothing but number of bits shifted towards the, towards which side here? Right side. How many bits to be shifted towards the right side? That is represented as what here? N. That is represented as a n. So value is there, n is there. For example, yes, just here. So what will happen? Suppose assume that, so there is one value. Suppose I just take A equal to 0B. Any value which is prefixed with 0B is called which value? Binary value, right? Any value which is prefixed with 0B is called which value? Binary value. So 0B 1010. 0B 1010. So how many bits are there? 4 bits. How many bits are there here? 4 bits are there. Okay, 4 bits are there. Okay, so what will happen? So memory is represented like this. Okay, so it is a memory of 1 byte. So is it memory is reserved in the form of bits or bytes? Bytes. Okay, bytes, right? Assume that this is the memory of how many bytes here? 1 byte is there. How many bytes are there here? 1 byte is there, right? So always the data is filled from right to left. Okay, always the data is filled from right to left, right to left, right to left. Now, what is the first one here? Now, 1, 2, 3, 4, 5, 6, 7, and this is what here? 8. So, total how many bits are there? 8 bits equal to 1 byte. 8 bits equal to 1 byte, right? Now, this is 0. 0 is placed in, this 0 is placed in which location? First location. And this is a 1. So, always it will fill the data from right to left. Right to left, right? Now this is 1 and this is again what here? 0 and this is again what here? 1. Okay, now within 8 bits, your value is taken how many bits here? 4 bits. Means remaining all are empty or not? Yes. And this is filled with what here? Zeros. This is filled with what here? Zeros. Filled with zeros. Now this indicates what here? Empty. Okay, this indicates what here? Empty, right? But your value is taken how many bits here? 4 bits. Then next, what I'm doing is I'm trying to write like this. Okay, B equal to A, right is shift to 2. 2 means how many bits I'm shifting towards the right side? 2 bits. Okay, 2 bits. But for moving towards the right side, there should be some space or not? To shift to right side, there should be some space or not? Yes, there should be some space. But is it any space is there? No. Is it any space is there? No. If space is not there, what will happen? Delete. If the space is not there, what will happen? It will delete. So how many bits you are shifting towards the right side? 2 bits. So move 2 bits means from here it will move how many positions? It will move how many positions? 2 positions, right? So what will happen? Suppose after shifting, now this is B. Okay, this is B, right? Now this is value of A. This is value of A. This is a value of, this is a value of which one? A. And this is a value of, this is a value of which one? B. This is a value of B. So total how many bits here? 8 bits, which is 1 byte, right? So 1, 2, 3, 4. So there's a 5. Okay, 8. Okay, now this is like this. So what will happen? 0 is shifted towards which side? Right side. It means this 0 is deleted or not? Yes. Then this 1 is moved here. But how many positions you are shifting? 2 positions. So 0 is shifted how many positions? 2 positions. So then 0 is deleted or not? Yes. Then 1 is shifted how many positions? 2 positions. But here how much space is there? Only 1. Then 1 is deleted or not? Yes. Then this 0 is shifted how many positions? 2 positions. Now, but is it space is there? Yes. Then what will happen? 0 will be shifted here and 1 will be shifted here. Okay. Then remaining all are blank or not? Yes. Now these are filled with what here? Zeros. All these are filled with what here? Zeros. All these are zeros here, right? So how many bits are deleted here? 2 bits. And remaining how many bits are there here? 2 bits. That is 1 and 0. So it means values incremented or decremented? Decrement. Now you can convert. You can convert this into which type? Decimal. So this is at which position? This is at which position? 0 position. And this is at which position? 1. And this is 2. And this is what here? 3. Okay, like this. And there is a 4. So there is a 4 and there is 5. And this is 6. And this one is what here? 7. So convert this binary to decimal. How you convert 2 to the power of 0? 2 to the power of 0 into what? 0. 2 to the power of 0 into 0 plus 2 to the power of 2 to the power of what? 1. Okay, into 2 to the power of 1 into 1 plus 2 to the power of 2 to the power of what? 2 into 0. Already I said how to convert, right? 2 to the power of 3. 2 to the power of 3 into 1. This is converting binary to decimal. Now that is nothing but 0 plus what? 2 plus 0 plus 8. And what is the value? 10. The value is a 10. Now after that, now this is how many values are there now? Again, 7. This is 7 and this is 6 and this is 5 and 4, 3, 2, 1, 0. So again 2 to the power of 2 to the power of 0, 2 to the power of 0 into 2 to the power of 0 into 0 plus 2 to the power of 2 to the power of 0 into 0 plus 2 to the power of 1 into 1. So what is the result here? 0 plus 2. And what is the result here? 2. Is it values incremented or decremented? Decrement. Okay, so whenever you shift number of bits towards the right side, the value is not incremented, the value is what? Decremented. But suppose in exam, if they ask these questions, right, then drawing it and doing it becomes very difficult. So what you can do is you can apply simple one formula. You apply the formula here. So what is that formula you can apply is, okay, value divided by floor division, value divided by value divided by, okay, value divided by 2 to the power of value divided by 2 to the power of n. So division means decrementing or incrementing. Division means decrementing or incrementing. Yes. Division means incrementing or decrementing. Decrementing, right? Multiplying means what here? Incrementing. Division means what here? Decrementing only, right? Yes. So memory is always reserved in bytes, not in bits, right? 1 byte memory, 2 bytes memory, 3 bytes memory. Why 8 bits, sir? Why 8 bits means? I didn't get. 1 byte equal to 8 bits. 1 byte equal to 8 bits. 1 byte. This is 1 byte. This is 1 byte. Okay, 1 byte. It will not reserve 1 bit space. Memory is not reserved in bit, 1 bit, 2 bit, no. Okay, it will reserved in 1 byte, 2 bytes, 3 bytes. Okay, yes. 1 byte means which is equivalent to 8 bits. Now you can apply this formula. You can apply this formula, right? Instead of doing that, uh, what is that? Drawing it and moving it 1010 and B equal to, if you are writing A, right shift to what? 3. I said 3 bits I want to shift. Then what is the A value? Same. What is the B value? You can apply formula. What is the formula? What is the value? 0B 1010, right? So 1010 equivalent of decimal is what? 10. So you have to convert that value into what? Decimal. And then divided by 2 to the power of n. 2 to the power of n means 2 to the power of 3. 2 to the power of 3. 2 to the power of 3 is 2 to the power of 3 is 8. So what is the result of this? 1. So what is the value of B? 1. Okay. So here value must be, here value, whatever value you write here, this value must be which value? This value must be which value? Decimal value. This value must be which value? Decimal value. But this value should not be what? Binary. If it is a binary also, you have to convert that value into what? Decimal. You have to convert that value into what? Decimal. Okay. Even though it is given in what? Binary format. Even though if it is given in binary format, so that value is converted to decimal, right? Suppose assume that, suppose if you are writing like this, okay, so A value is 10 and B value is A right shift to 2. Now this value is binary or decimal? Decimal. But how it will do the operation? By converting this decimal to what? Binary. And shift how many bits towards the right side? 2 bits. This is A value, B value. And you can see binary of A, and then you can see binary of which one? B. So how many bits are deleted here? 2 bits are deleted. How many bits are deleted here? 2 bits are deleted and remaining bits are only? Yes. If I'm writing A equal to 0, B 101010 like this. Okay, I've taken some randomly. Now 10101010 like this. Okay, if I'm saying B equal to A right shift to what? 4. Means how many bits get deleted? 4 bits. The remaining how many bits are there? 4 bits. Now what is the value becomes 10. Now you can print in binary of A and binary of which one? B. So if you print a value by default, you are ideally print a value in which format? Decimal format. So what is the value of B here? 10. Okay. So you can give the value either in decimal format or you can give the value either in what? Binary format. Okay. If I'm writing A equal to some value, suppose 170, A equal to 170 and B equal to, okay, A right shift, how many bits I shifted? 4 bits. So what is 170 equivalent of binary? You can see here. Print binary of which one? A. So this is a binary of which value? 170. Okay. Then within this it will shift how many bits? 4 bits. Then remaining how many bits are there? 4 odd. Or you can apply the formula 170 divided by 2 to the power of 4. 170 divided by 2 to the power of 4. Even that also can do it. Now this is A value and this is B value in which format? Decimal format. So this is a value. Yes. Now this is how you are shifting towards the left side and Okay, now towards the right side. Now this is called as a right shift operator. And there is one more operator is there, and that is called which operator here? Left shift operator. There is a right shift operator and there is a left shift operator. But I said no, this binary operator. Suppose if I'm writing 1.5 right shift to 2, 1.5 is which value? Integer or float? Float. Okay, 1.5 is not integer, right? 1.5 is a float. Now can you apply? No. So bitwise operations only on which type? Integers. So immediately it is given error saying that unsupported operand type for redshift here. Okay, yes. Float and you cannot convert float and what here? Integer. If I'm writing now within double quotes, I just write A, which is called as a string. Sorry. Within double quotes, I write A, which is a string and shift. Again, it is given what? Error. So only on which data types? Integer data types. But that integer can be represented in decimal, octal, hexadecimal, but internal it converts into what? Binary. So this is a left shift operator. Left shift operator. Okay, now this operator, okay, this operator, okay, this operator, okay, this operator is use it for incrementing value. This operator shifter, this operator shifter, number of bits towards which side? Left side. So this operator add, actually this operator, what it will do? Add bits at which side here? Right side. Okay, now when you add bits, what will happen? The value get increment. So left shift operator increment values. Okay, the left shift operator increment value by adding bits. By adding what here? Bits. Now it is also binary operator. So what is the syntax of this value? Left shift to what? N. Value left shift N. So your value must be which one? Binary value. If it is any other value, it converts into which value? Binary value. Or you can give, okay, if you say here decimal or so your value can be decimal, binary value or decimal value or octal, or it is in what? Hexa. But it converts, P1 converts into which type? Binary type. If you give in other formats, it converts into which one? Binary. N is nothing but number of bits. N is number of bits. Number of bits shifted towards which side? Left side. How many bits you want to shift it towards the left side? So that is represented by using which one? N. So that is represented by using which one here? N. N is there. Now please try to understand this. Very simple it is. Okay, so what exactly it is? Now it is like this. For example, so again you take, suppose there is a value A, so A equal to 0, B, some again I've taken 1 0 1 0. So it is in which format? Binary. But if it is decimal, you have to convert into binary. If it is decimal, for example, 25 is a, so 25, and if I say B equal to A right shift some 3, sorry, A left shift 3. So what is the value? 25, and A left shift what here? 3. Now what will happen? It will shift directly on 25? No. You have to convert this 25 into what? Binary. 25, how you convert? By dividing with the 2. Divide this 25 with what here? 2. So this is how you convert it. So how many times? 12 times, and remainder is a 1. So this is how you convert into binary. So then how many times here? 6, and remainder is what here? 0. So then how many times here? 3 times. And what is the remainder here? 0. So again, how many times here? 1 time. And remainder is a 1. So again, you divide this 1 with a 2. But is it divisible? No. Then what is the remainder here? 1. So what is the value? 1, 1, 0, 0, 1. So what is the value of A? The value of A is, the value of A is what? 1, 2, 3, 4, 5. 5 bits, right? Remaining 3 bits are what? Zeros. Okay, 0, 0, 0. What is this? 1. So there is a 1. So 1, 0, 0, 0, 0, 1. So these are 8 bits. For which one? A, right? This is for A. This is for A, right? It is like this. Okay, so this is for which one? A. But you are shifting how many bits towards the left side? 3 bits. Okay, 3 bits. Now, but is it enough space is there or not? Yes. If not space, then it will allocate memory for one more byte. Because I said no, fill is done from right to left. Right to left. Suppose if there is no space at left side, it will create one more byte and then shift it. But it will not delete. But it will not delete. Right? Yes. So B is there. B is there. Okay. Yes. B is there. What B is having now? It is shifted how many bits towards the left side? 3 bits. Then what is my value becomes? Okay, what is the value? Now, how many bits are added at right side? 3 bits. Okay, what is the value? 1, 1, 0, 0, 1. Remaining 3 bits are what again? Zeros. 0, 0, and 0. So from here, it is moved. From here, it is moved how many bits? 3 bits. Now, 1 is shifted here, and this 1 is shifted here. 0 is shifted here. This 0 is shifted here, and 1 is shifted, and remaining bits are filled with what? Zeros. So if you add any bits at the right side, that doesn't indicates blank. That indicates value get what here? Incremented, because fill of data is done from right to left. Filling of data is done from right to what? Left. Okay. So this is, what is this? 7, 7, 6, 5, 4, 3. Okay, 5, 4, 3, 2, 1, 0. Okay, now this is also 7, 6, 5, 4, 3, 2. Sorry. Okay, 3, 2, 1, and this value is what here? 0. So it is like this. Now that is shifting. number of bits towards the left side and shifting number of bits towards the right side, right? But this is which side here? Left side. Now you have to convert this. How 2 to the power of 7 into 1 plus 2 to the power of 6 into 1 plus 2 to the power of 5 into 0 plus 2 to the power of 4 into 0, 2 to the power of 3 into 1, 2 to the power of 0 into 1, 2 to the power of 1 into 0, and 2 to the power of 0 into 0. But that will take a lot of time or not? Yes. You can apply simply one formula. So you can apply one formula. So what is that formula is? Simply you can apply. Formula is value into 2 to the power of n. Now multiply. So what is that? 25 into, what is my value? 25 into 2 to the power of 3. 2 to the power of 3 is what? 8. Then what is the result? What is 25 into 8? How much? 200, 200, 200. Yes. Now you can just check here. Okay, suppose A value is what is the value of A? 25. What is the value of B? A left to shift toward 3. So print the value of A, which is 25. Print the value of B, which is 200. So print binary equivalent of A. This is binary 110 11 111 yes. If I say print binary of which one? B. So how many bits are added here? 3 bits. Now it's nothing but 11 here. 11 001 000. Okay. So the value becomes what here? 200. Okay. So you can directly convert decimal to binary and apply the operation. Otherwise, you can apply directly. So apply this formula and do it. Okay. Anything you can do here. So this is how you are working with it, right? So A value is 25 and B is A left shift to 3 and like this. Now this you can call it as which shift operator? Left shift operator. And this is which operator? Right shift operator. By shifting bits, what you can do? Increment value or decrement value. By adding the bits and by removing bits. Now generally it is used in memory management by the operating system, right? Then next is you have a bitwise. Other operators are there like bitwise and bitwise or bitwise what? Exclusive or. Actually, these operators are used for applying. So these operators like bitwise what here? And operation. Okay, there is a bitwise or operation. So there is a bitwise exclusive XOR operation. And there is a bitwise, it's called as a NOT operator. So actually these operators are used to apply which one? Logic gates. Actually these operators are used for applying which one? Logic gates. Okay, when you are working with some embedded applications, now you apply the logic gates by using AND or exclusive OR, and one more is what? NOT, right? And or exclusive OR and one more is a NOT. But I said no, what is a logic gate? Okay, a logic gate. Okay, yes, this is a definition for general knowledge because you are not working with any embedded applications, but In technical round, they may ask you the questions related with the bitwise operators, but you should have a knowledge of it. Okay, you must have the knowledge of this here. A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to what? Digital circuits. Most electronic devices we use today will have some form of which one? Logic gates. So there is AND gate. Now this is for applying which gate here? AND gate. So this is AND gate here. Symbols are there. And this is applying which gate here? OR gate. And this is applying which gate? XOR gate. And this is for applying which gate? NOT gate. So all these are logical gates. Okay, now if you see the truth table, now I just write truth tables of all this. Now see, you can also see the symbols for this here. These are the logic gates. You can find the symbols right here. This is AND, OR, NOR, NOT, NAND, XOR, right? So these are different symbols even you can use, right? And you find some truth tables. Now you can find the truth table for each logic gate. Now you can see this is for NOT, this is the input and this is what here input output, and these are the inputs and this is what here output, and these are the inputs and these are output. See, OR is there, and these are the inputs and this is what here output. You send how many inputs to this logic gate? Two inputs, and you get which one? One output. So based on the inputs bit, and you are applying some logic here. What is the logic? OR. And here you are applying which logic? AND. But you input two bits, 0, 1, then you'll get the result. You input 0, 1, you get some result, right? Yes. But how this is? So we have this, but NOT is there, AND is there, OR is there, and which one is there? XOR. This is called as exclusive OR, and NOR is not there. We'll just remove this one. Okay, now, right? This is not there. Which one is not there? NAND is not there. And there is a, now you can apply it. You can apply it. Okay. Not there means don't think that not separate operator is not there. NAND means and not and not. You have to apply how many operations? AND operation as well as not operation. Okay. So don't think that not there means it's not there. No. Okay. You have to use multiple operations. You have to use multiple operations here. Okay. Now this is bitwise and OR, and this is bitwise. Which operator? Sorry, which one it is? Exclusive OR. This is exclusive OR, and this is bitwise not. So even truth tables are there. Okay. Yeah, this is inputs, and this is what here? Outputs. If first in input bit is 0, 0, then output bit is what? 0. 0 and 0 is what? 0. But it is not true, right? Because here it is in 0, 0 and 1. 1, 0 is what? 0, and 0, 1 is a 0, and 1, 1 is a 1. So these are the truth tables here. These are the truth tables for these operators here. So I just taken the operators along with the, what do you call it, as pictures, right? Okay. Yes. So these are used in electronics, but we are not talking anything about which one? Electronics. But as a Python developer, you must have the knowledge of this. That's it. Okay. Now suppose AND operation is there. If we take AND operation, I'll write like this. Okay. If you take AND operation, now, so there is a, okay, there is A, which is, see, I try to send 0B, 1 0 1. Okay, B is there. Now it is the binary operators and 0 B 1 1 0. Now first you are sending 1 and 0. 1 0 becomes what? 0. And 0 1 becomes what? 0. And 1 1 becomes what? 1. When if you are applying which operation? AND operation. AND operation. In AND operation, what will happen? 0 0 is what? 0. And 1 0 is what? 0. If any one input bit is 0, output bit is what? 0 only. If any input bit is 0, then output bit is what? 0. If any input bit is 0, then output bit is also 0, right? So 1 0 is 0, 0 1 is 0, and 1 1 is what? 1. 1 1 is a 1. So what is the result of this? 1 0 0. If you want, you can put print binary of which one? A. So print binary of which one? B. And print binary of which one? C. What is the value of C? 1 0 0. You can print in decimal A, B, C. Now this is in which format? Decimal 5, 6, and 4. So AND operation. This is called which operation here? AND op. Suppose if I'm writing 0 B, suppose some A equal to 0 B, 1 0 1. Okay, B equal to 0 B. Okay, 0 B, and I just write here 1 0. Okay, 0 B, what is that? Oh, sorry. A equal to 0 B, 1 0 1, B equal to 0 B, 1 0. Okay, now, so this is having how many bits here? 3 bits, and this is having 2 bits. And I said always fill is done from right to left. So this becomes what? 0 B 1 0 now, 0 B 0 1 0. This becomes 0 B 1 0 or 0 B 0 1 0, 0 1 0. So then what is the result? 1 0 becomes what? 0. And 0 1 becomes what? 0. And 1 0 becomes what? 0. If I say C equal to A and B, so what is the value of binary of A is? This is binary of A, and this is binary of B, and this is binary of which one? C, which is what? 0. So binary A, B, C. What is A value? 5. B value is a 2, and C value is what? 0. And this is in which format? Decimal format. You have to write. So only what you have to do is you have to apply the table. Only the thing you have to do is you have to apply the table. Okay? Yes. So you have to apply this logical, gate table you have to apply. This table you have to apply, right? So this is and this is what here or is there. So there is a or. A equal to 0 B 1 0 1 0 and B equal to 0 B 1 1 0 0. So if it is or, suppose C equal to A or B. Or means not OR. OR is a logical. Pipe is what? Bitwise. So 0 0 0 1 0 is 1, 0 1 is 1, 1 1 is 1. So it becomes 1 1 1 0. It becomes 1 1 1 0. So binary of A, comma binary of B, comma binary of C. So what is binary of A? 1 0 1 0. What is binary of B? 1 1 0 0. What is binary of C? 1 1 1 0. You can also print directly A, B, C. A is 10, B is 12, C is what? 14. Okay, so it is applying which operation? Which operation? Bitwise? Bitwise which one? OR operation. OR operation. Suppose in bitwise exclusive OR operation, what will happen? Suppose if any 2 bits are equal, the output bit is, suppose if any 2 bits are equal, then output bit is 0. 0 0 is 0, 1 1 is also 0. But 0 1 is a 1, 1 0 is what? 1. If any output bit is 1, then any output bit is 1, input bit is 1, then output bit is what? 1. But if two input bits are equal, then the output bit is what? 0. If two input bits are equal, then output bit is what? 0. So that is what will happen if you are working with exclusive OR operation. Now, if you see the same example, 0B 1010 and B equal to 0B, 0B double 100. So 0 is what? 0 and 10 is 1. 0 1 is 1, but 1 is a 0. If I am applying which operator? Exclusive OR operator. So print binary of A. So binary of A and binary of B and binary of C. So 110, you can print directly A, B, C, that is 10, 12, and one more value is what? 6. Now this is in which operation? Exclusive OR operation. Exclusive OR operation. Now suppose if I'm writing A equal to 0, B 1, then B equal to not A. B equal to not A. So what is binary of A? This is binary of A and this is binary of what? B. So what is binary of A? What is binary of A? So here 1, this is plus. And what is a binary of B? This is what here? Minus. So it will use one formula. Suppose if I'm writing print A comma B, what is value of A? 1, and what is value of B? Minus 2. But how takes minus 2 here is it takes not means it takes two complements. So if you want you can do calculations, or simply you can apply one formula. Simply you can apply one formula for bitwise. You can apply one formula for bitwise not operation. And what is that formula you can apply is, if you are working with this bitwise not operation, okay, so what you can do is minus of, so minus of, okay, so what is that? Value plus minus of value plus 1. Simple. Minus of value plus 1. Result is minus of value plus 1. So this is a formula used for bitwise what here? Not operator. Otherwise you have to take 2's complement and then you have to add 1, then you will get the result. That takes a lot of lengthy process. You can simply apply minus of value plus 1, but here value should be in what? Decimal. Value should be in what here? Decimal. Suppose if I'm writing like this, suppose the value of A is a 10, the value of B is not A. Tell me, minus of value plus 1 is nothing but 10 plus 1 is a 11. So this value of A will be what? 10, B value is what? Minus 11. Okay, suppose if I'm writing A equal to minus 11, B equal to not A, B equal to not A means minus of minus 11 plus 1 is minus 10. Minus of minus 10 becomes what? Plus 10. Plus 10. Then what is the A value? Minus 11. B value is what? 10. So print binary of A, print binary of A and print binary of what? B. Binary of A and binary of B. So that is 1010 and this is 1011. Yeah, please just to try to understand here. Okay, so bitwise not so important. As a Python developer, not so important, but as an embedded developer is required. Okay, if you are moving towards embedded applications, then this bitwise operations are required because every programming language provide this. It's not Python only, any programming language like C or C++, Java, .NET, any programming language you learn, you find this bitwise operators. Bitwise operators. This is about bitwise operators. So there is one more category. What is it? One more category of operator is it this is clear, right? Only bits, right shift, left shift. So this truth table, take this truth table and apply the logic. Take the truth table and apply the logic here, right? Yes. There is one more category of operators like there is an identity operator. There is an identity operator or membership operators here. Bitwise operator, and after this, what next one? Membership operator. Membership operator is there. Membership operator. So what is this membership operator here? What is this membership operator here? Membership operator. See, these are very much useful. Membership operators, very, very important operator. This is, you don't find this operator in any other language, this membership operators, identity operators, but this you find only in what? Python. So membership, generally it is used on which data type? Collection data types. Collection. Suppose if this is a classroom. In this classroom, there are so many students are there. I want to know, is it one member is there in classroom or not? So membership operators are used for what? Searching. It is used for searching. In other languages for searching, you have to write lengthy program. But here searching is only one statement. Only one statement. That is the beauty of Python. You don't require to write lengthy code. You don't require to implement number of algorithms. No, you just write simply one statement. Suppose there is one collection is there. Collections. Collection types are there. For example, string is there. String is one collection or not? Yes. For example, Naresh is a string. Inside this, I want to know A is there or not. Inside Naresh, is it A is there or not? Then what will I do? Membership operator I'll use. A in Naresh. Is it A is there inside Naresh? Is it A is there inside Naresh or not? Yes. It is there. Then what it returns? True. Searching only. Right? This is searching or not? Yes. It's searching for which character? A character inside string. Is it A character is there in string? Yes. So it is written true. Suppose if I'm writing capital A in, if I'm saying capital A in Naresh, capital A is there in Naresh? No. What is the value written? False. I have a collection of phone numbers. Phone numbers are there. I want to search. Is it this phone number is there or not? How can I search? Just use in. Is it this number is in a list of numbers? Okay, is it this phone number is there inside what? List of numbers. List. List is what here? Collection. List is one collection. Inside that, you are searching, these values exist or not. So membership operators. Now we'll discuss this otherwise, how to work with this membership. Maybe in the next class, we'll finish this. What is this operators like membership and other and conditional, and then we'll go for collection types. Collections means like control statements. We'll see control statements, but before control statements, we'll go for collection types and then we'll come back to what? Control statements. Okay, anyway, we can do it. Okay, collection types are what? List, set, dictionaries. List, tuple, range, list, tuple, range, bytes array, string, all these are sequences. I said no, collections are classified into three: sequences, sets, and mappings. So you know Python, then you must know these collections, right? So we'll discuss that. In the next class, that is on Monday, we'll say, right? Monday, I'll start early because nowadays I'm starting late, right? So Monday, we'll start by 7:15, 7:20 maximum, right? So we'll stop it here and Monday we'll continue this, right? Thank you, right? आपको ऑर्डर बोले तो और एक बैच में अटेंड हो जाइए. एक्सक्लूसिव आ रहा है. नहीं वो 000 है. और टेबल है ना, वो टेबल में देखो यार. हाँ, टेबल में देख के करना हो. हाँ, एक्सक्लूसिव आर टेबल है ना, और टेबल के अंदर देखो. ओपन